Assalamu alaikum. This is Muhammad Ishadul Haq from CSC 431, and this is our fourth assignment. And this assignment is on paper review, and my topic is dynamic sentence boundary detection for simultaneous translation. So let's get started with introduction and background part. So let's give an introduction first. Simultaneous translation aims to translate the speech of a source language into a target language as quickly as possible without interrupting the speaker. Typically, a simultaneous translation system is comprised of an auto-speech recognition or ASR model and a machine translation or MT model. The ASR model transforms the audio signal into the text of source language, and the MT model translates the source text into the target language. Now let's talk about background. Recent studies show that the pre-training and fine-tuning framework achieves significant improvements in various natural language processing tasks. Generally, a model is first pre-trained on large unlabeled data. After that, on the fine-tuned step, the model is initialized by the parameters obtained by the pre-training step and fine-tuned using labeled data for specific tasks. Now I'm going to talk about the methods and experiments they have used in their paper. So let's talk about methods first. So here's the method slide. So method slides, there are three segments. You can see the model, training objective, and then dynamic interface. Let's talk about the model first. So for streaming input, X is a set of X1, X2, and then Xt, and their goal is to detect whether there is a sentence boundary Xt minus capital M plus 1. Generally, more contextual information will help the classifier improve the precision. And then the training objective. Their training data is extracted from paragraphs, question marks, exclamation marks, and semicolons are mapped to periods, and all other punctuation symbols are removed from the corpora. Then for every two adjacent sentences in a paragraph, they concatenate them to form a long sequence of X. Then they record the position of the period as R, and then they remove the period from the sequence. And then dynamic inference. At inference time, they predict sentence boundaries sequentially with a dynamic voting strategy. Each time a new word xt is received, they predict the probability of capital M plus 1 classes as shown in the right side of the slide, and then M plus 1 position is larger than a threshold theta. If yes, they add a sentence boundary at the corresponding position. Otherwise, they continue to receive new words. After that, they have done some experiments according to their methods. So let's have a look on experiments. So first of all, the overall result, and then magic in data processing, then length of window, and then number of feature words M. So let's start with magic in data processing. So here, according to the training objective, the order between sentence of origin corpora would affect the generation of training samples. So in this section, they investigate the effect of various data recording strategies. And then the length of window. So here they discuss the effect of changing theta or the length of window, the performance of dynamic force with varying length of window is shown in the table below. And then smaller the length is, the smaller length brings shortly latency as well as worse performance. The effect is extremely poor with length 10. So there are two possible reasons: constrained sentence length less than the theta is too harsh under small theta. The discrepancy between the unrestricted training and length restricted testing causes the poor effect. then the number of feature words. They investigate whether can they achieve better performance with more or less feature words. They experiment the m from 0 to 5. The result is shown in the slide just below in the right side. And then related work. Sentence boundary detection has been explored for years, but the majority of this work focuses on offline punctuation restoration instead of applied in simultaneous translation. Existing work can be divided into two classes according to the model input. So first one is n-gram based methods and the second one is whole sentence based methods. What is n-gram based methods? So some work takes a fixed size of words as input, focus on utilizing a limited size of the streaming input. They predict the probability of putting a boundary at a specific position xt by n-gram language model or a classification model. The classification model takes features of n words around xt and classifies to two classes denoting x1 is a sentence boundary or not. The main deficiency of this method is that the dependencies outside the input window are lost, resulting in low accuracy. And then whole sentence based methods. Some other work focuses on restoring punctuation and capitalization using the whole sentence to improve the sentence boundary classification accuracy. Some work upgrade the n-gram input to variable length input by using recurrent neural network. And after that, conclusion. So in this paper they propose an online sentence boundary detection approach. With the input of streaming words, their model predicts the probability of multiple position rather than a certain position by adding the adjacent position constraint and using dynamic prediction. Their method achieves higher accuracy with lower latency. Thank you. Excuse me, sir, I forgot to bring my ID card at home. I just left it in Dhaka, so that's why I had to take screenshot from the Baku app and I just put it in here. Thank you.